Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1158, indicates a communication failure between the gauge control module and the relay control module in Honda Odyssey models from 2011 to 2017. The gauge control module is primarily responsible for displaying various gauged readings on the dashboard, such as speed, fuel level, and engine temperature, while the relay control module manages electrical circuits to ensure that various components function correctly. The lost communication suggests a malfunction in the system that can lead to inaccurate readings or complete failure of the gauge cluster. This could potentially affect the vehicle's performance and safety monitoring functions. To address this DTC, it is crucial to understand the components involved, their locations in the vehicle, and the underlying issues that could contribute to this fault. In troubleshooting, the Honda Diagnostic System, HDS, is used extensively to clear and interpret DTCs, providing insight into the vehicle's electronic health. DTC B1158 points to a disruption in the data communication between the gauge control module, GCM, and the relay control module, RCM. The GCM, located on the dashboard, processes signals related to instrument readings, while the RCM, found in the engine compartment, distributes power to various electrical components. When communication is lost, the GCM cannot accurately track or present vital information from the vehicle's sensors. Affected components include the wiring harness connecting these modules and any associated connectors. Poor connections can lead to voltage drops or intermittent failures. In some cases, the issue may result from a software glitch or failure within the modules themselves. It is essential to conduct a thorough inspection of these components and their connections to identify the root cause of the communication loss. Several factors can lead to DTC B1158. One primary cause could be loose or corroded connections between the gauge control module and the relay control module, resulting in signal interruption. Another potential cause involves faulty modules, where either the GCM or RCM might be malfunctioning due to internal defects or software issues. Electrical interference from other vehicle components can also cause disruptions in communication. Additionally, issues in the body CAN, Controller Area Network, bus, which allows communication between components, may contribute to this DTC. Lastly, blown fuses in the circuit that feeds power to these modules could prevent operation and the establishment of a communication link. Proper diagnostics using the HDS and physical inspections are necessary to pinpoint the exact cause. The symptoms associated with DTC B1158 include erratic or absent readings on the dashboard gauges. You may notice that speed, fuel level, or temperature readings are not functioning as expected, which can lead to confusion while driving. In some cases, dashboard warning lights may illuminate, indicating malfunctions in the vehicle's electrical system or that specific gauges are non-operational. Additionally, you might experience situations where functional gauges entirely fail to respond, making it difficult to assess vehicle performance. All of these symptoms can affect the driver's ability to monitor key information crucial for safe driving. The severity of these symptoms can vary, but they emphasize the importance of timely diagnosis and repair to ensure continued safe operation of the vehicle. Begin troubleshooting DTC B1158 by utilizing the Honda Diagnostic System HDS. First, ensure that the HDS is equipped and ready for use. Clearing the diagnostic trouble codes with the HDS will help reset any false errors that may have been registered in the control modules. This step is essential because it allows you to monitor if the issue reoccurs, or if it was a transient fault. Once the codes are cleared, you can start the diagnostic process by turning the ignition switch to the lock position and then back to the on position after a few seconds. This cycle prepares the vehicle systems for a fresh communication check. It is essential to follow these steps as outlined to ensure accuracy in diagnosing the issue. After clearing the DTCs, turn the ignition switch to lock 0 and then back to the on 2 position. It is crucial to let the vehicle systems initialize for at least 6 seconds. During this time, various electronic modules run self-checks to establish proper functioning and communication pathways. Following this wait period, you'll need to check for any active DTCs using the HDS once again. This newly obtained data will help determine if DTC B1158 has returned or if it was merely a sporadic issue. It's essential to conduct this step accurately as it helps identify if the problem persists, guiding your next steps in the troubleshooting process. Now, check if DTC B1158 is still indicated on the HDS. If the DTC remains present, this confirms that a persistent communication error is occurring between the gauge control module and the relay control module. This signifies that the initial issue has not been resolved and indicates further investigation is necessary. On the other hand, if the DTC does not appear, this could suggest an intermittent failure, possibly related to a loose connection or momentary disruption in communication. In such cases, it is advisable to check for any loose or poor connections between the modules involved. Identifying and rectifying these inconsistencies is vital for maintaining system integrity and ensuring accurate gauge readings moving forward. In this step, access the Body Electrical System Select menu on the HDS and choose the option for BCAN Control Units Information. This feature allows you to see a list of all connected control units within the Body Controller Area Network, BCAN. The aim here is to determine whether the relay control module is detected by the HDS. If the relay unit is recognized, this indicates that communication is being established to some extent between the modules. If detected, you will proceed to the next troubleshooting step. However, if the relay control module does not appear in this list, it implies a deeper issue with communication or connectivity in the system, warranting further investigation. If the relay control module is not detected, the next step is to measure the voltage at connector B16P, terminals number 9 and number 10, which are crucial for determining if the module is receiving the necessary power. It's important to ensure that you measure each terminal individually to accurately gauge battery voltage. If battery voltage is present at these terminals, this indicates that power is reaching the relay control module, guiding you to further diagnostic measures. If voltage is absent, it points towards an issue in the power supply circuit, which necessitates closer examination. This step is critical, as it determines whether the problem lies with the power supply or within the module itself. After measuring the voltage, if you confirm the presence of battery voltage at the terminals, proceed to step 9 for further checks. However, if voltage is not detected, you will need to turn the ignition switch to the lock position. At this point, the next action is to check the number B6 7.5A and number B16 10A fuses located in the underhood fuse relay box. Ensuring these fuses are in good working order is essential, as blown fuses could prevent power from reaching module components. Additionally, faulty circuits can lead to communication errors, exacerbating the DTC. Therefore, thorough inspection of these fuses and circuits is critical in the troubleshooting process, identifying any weak points or necessary repairs. Within this step, check the integrity of the number B6 B1158-7.5A and number B1610A fuses located in the underhood fuse/relay box. If the fuses are operational, indicating they are intact, this suggests the circuit may have high resistance or an open, which needs to be repaired. Conversely, if a fuse is blown, it will need to be replaced immediately. If replacement does not resolve the issue, you'll want to investigate for a potential short to ground in the circuits associated with these fuses. Circuit issues can lead to loss of power, creating communication failures between components. Thus, this thorough evaluation and subsequent repairs will play a vital role in restoring communication integrity within the system. Finally, if you confirmed the fuses are intact, the next step involves measuring the voltage between body ground and the relay control module at connector B16P, specifically at terminal number 1. This terminal connects to the ground signal of the module, crucial for proper functionality. By ensuring a proper ground connection, you can identify if the relay control module is functioning effectively. If the ground voltage is absent, further investigation into the module's integrity and connections is essential. Always approach this step with careful consideration, as ensuring all connections are up to standard is vital in facilitating continuous communication and averting further DTC occurrence. After completing the appropriate repairs related to DTC B1158, it is crucial to verify the effectiveness of the fixes. Begin by clearing any remaining DTCs using the HDS and running the ignition cycle once more. Assess the functionality of the gauge control module, checking that all gauges respond accurately and correspond with their sensor readings. Conduct a thorough test drive to ensure all systems operate smoothly without triggering the DTC again. Keeping a vigilant eye on the vehicle's performance during this period will help identify any ongoing or new issues. If the DTC does not reappear and all functions return to normal, the repair process can be considered successful, assuring the vehicle operates as intended. That's all. Preventive maintenance is key to avoiding future occurrences of DTC B1158. Regular inspections of wiring harnesses, connectors, and module integrity can help catch issues before they escalate. Monitoring the health of electrical components, including relays and fuses, will contribute to the overall reliability of the vehicle's electrical systems. Moreover, keeping up with software updates from Honda can ensure that all control modules operate correctly and efficiently. With these simple preventive steps implemented regularly, vehicle owners can help mitigate the risk of communication failures, enhancing the overall performance and longevity of their Honda Odyssey. In conclusion, understanding DTC B1158 involves comprehensive diagnostics of the communication link between the gauge control module and the relay control module. Effective troubleshooting entails multiple systematic steps to ensure that both modules and their connections are functioning correctly. Identifying the root cause of the issue, whether it be faulty modules, poor connections, or blown fuses, enables successful resolution. Additionally, following up with preventive maintenance can help mitigate the recurrence of similar issues in the future. Through diligent inspections and awareness of vehicle electronics, Honda Odyssey owners can maintain their vehicle's operational efficiency and safety. Always prioritize proper diagnostics and repairs while seeking guidance from certified professionals if uncertainties arise. Please like and subscribe to the channel. See you next time!